مواضيع بقية محطات الطاقة يعني. شكرا جزيلا. متحدثنا الأخير في هذه السيشن المهندس محمد كمال جابر، هو بايبنج وبايب لاين انجينير في شركة بتروجيت، وهيكلمنا عن الجاز ايرلي برودكشن فاسيلتي. اتفضل يا محمد. محمد قدامك 10 دقايق. ماشي.
Thank you, Mr. Chairman, for this introduction. Ladies and gentlemen, our most distinguished audience, I know that I'm here very late, and you are, of course, in rush. You would like to have your lunch now, but I will make sure that you will have the greatest benefit of my presentation. Well, being a part of a project company, a mega project company, which is covering the projects from Iraq up to Algeria, we are always looking for more challenges and new opportunities. I'm here to speak to you about the gas early production facilities. These will be our objectives. Natural gas, a promising industry in Egypt, and we'll go through an introduction to gas early production facilities, and then we will have a case study has been done through Btrojet. Well, the Capital Economics has estimated in Tuesday, 6th of February, that the GDP is going to have an increment up to 2.8%. And for those of you who are not familiar with the GDP, it's growth domestic production, which is indicating the consumption and exportation of a certain industry. Also, the Capital Economics has estimated that we are being blessed by new discoveries and new production, which is going to be almost doubled from 5 billion up to 9 billion. This could be good news for you, but I will not say sad news, it is worried news. Because if you have been awarded your fortune, you will be spending all the night thinking what I'm going to do with it to have the greatest benefit. So we will need an effective solution, not efficient solution, because of, you know the difference between efficiency and effective. Efficiency is doing everything on the right way, but effective is doing only the right thing. This takes us to an introduction to the gas early production. Before going to the EBF, we need to have small production, very simple about the gas itself. Its compositions, its definition, its classification. It's a mixture of hydrocarbons, of course, if you know, between hydrogen and carbons. It could be having some components. Yes, I have to also go through the types of gas wells, which are oil well, associated gas, and condensate well, non-associated gas, and gas well, pure gas, and also unassociated gas. These are some illustrative figures. Could be beneficial to show you the difference between, the different non-associated gas and associated gas. Of course, all of you are familiar with these items. The examples of hydrocarbons components could be, of course, CH4, C2H6, and C3, and then going below down to the lower and heaviest components, which are C4H10 and IC4. The gas could be classified, as we know, to sales gas, LPG and LNG, and NGL and condensate and removed substance. This figure could be illustrative for you. I'm pleased to take care that we will need this figure to know that the sales gas, which we are going to produce through our early production facilities, has to combine some of the nitrogen, CO2, CH4, C2H6, and of course, T3H8. The main gas components could be principal components, which are CH4, C2H6, and heaviest components, which are propane and butane. I'm reviewing these items because I will need it through my presentation, how I'm going to separate these light components from the heaviest components in the most, I will not say cheapest, most economic and fastest track. The gas processing is simply separating the heaviest from the lightest to produce what is known as gas, as per the client specs. The main steps are oil and condensate removal, water removal, H2S, CO2 removal, if your gas is sour gas, of course, and then sales gas producing and transport. Of course, dehydrate injection recovery, and all of you, I think, is familiar with the hydrate formation problem which we are facing when we are processing and treating our gas. We will need some certain items to know and define before going through our presentation, which are hydrocarbon and water dew point temperature curve. This is a curve, and I think it is familiar to all of you. The red one is hydrocarbon dew point, and the blue one is for the water. There is also the Kirkundum bar, which is highest temperature at which liquid and variable phases could exist together at equilibrium. And Kirkundum theorem is the highest temperature at which liquid is formed. This is simply a simple figure showing the gas early production. It is simply mounted scale equipment which are being gathered in front of each new discovered wells. Because if you are having many wells, you will not be spending your money to invest in a central process facility. And this central process facility could cause you a lot of time, a lot of money, and then these wells could cut off immediately. So we are gathering some equipment which are skid mounted, as we see. High pressure separator here, and then injection point for the hydrate formation, and then we are having our JT skid. JT skid, if you are not familiar with this item, it is standing for the Joule-Thomson effect. The Joule-Thomson effect is expansion valve for making the gas suffering from higher pressure drop, and at this moment it will be suffering from higher temperature drop, and then you will be able to separate the lightest component from the heaviest component through the low temperature separator. And also you will have this heat exchanger which could be working for both targets, heating the separated heaviest components and also making the temperature of the gas reasonable and matching with the EGBC gas specs. And then you are having the low pressure separation here for separating the heaviest components, and then to have the hydrate which is mixed with water to be injected again on this injection point, and then flaring a little amount of gas. Then you have your dry gas. This takes us to a case study which has been done through the Unisim software. These were the composition of our gas, as we see here, and these are the conditions. And the sales gas which were required by the client, as we see here. Our challenge is to separate these light components, methane and ethane, from the heaviest components here, and also to transport these conditions to the required specs. The main target here, as we see, with the dew point of the dew point temperature of the water, which is around 50 degrees Celsius, it needs to be transferred to around 0 degrees Celsius. Also keeping in mind to have the heating value as it is. So let's do this together. These are the conditions and the compositions. This is our figure, but keep in mind that this figure was considered on the dry basis, so we have to do some saturation with water to make it more real. So this will be our starting curve. These are the inlet conditions. This is our starting curve. The red one is our operating point. So how are we going to produce the sales gas? We will firstly we will remove the heavy components, then we will remove water and prevent hydrate formation, and then you will produce sales gas. We are going to do that by having this point inside the curve itself to create a two-phase flow, so we can separate the heaviest from the lightest, and then bringing the operating point back outside, as we see. So how are we going to do that? This is our process simulation, which is composed of inlet separation. And then you are having methanol injection, and you have your jet skid, and then you have your compressor station. And the reason why we are having our compressor station, as I mentioned previously, the main phenomena of the JT skid is to produce or to make the gas suffer from higher pressure drop. So that you lose your pressure, so you will have to use a compressor station to be matching with the sales gas specification. And then we are having a methanol regeneration to be re-injected. And also we are having our heavy components, which has been produced through the high pressure separation and also through the low temperature separation. They will be gathered, and then they will be separated again and then trucked to be treated furthermore. Kindly remember the steps. We will bring this point inside the curve, and then we will have it back. This is our curve, but if you if you notice that the operating point is so close to the curve of the dehydration or water creation, so we will have to do dehydrate for the injecting for dehydrate problem. This is our formation temperature for the dehydrate. It's around 18, so close temperature. For that, we are going to do the injection, dehydrate injection. We used the methanol because it is more economical, and the certain or the main reason the lowest temperature at UJT downstream is still above the hydrate formation temperature. As we see here, it's around minus 0.11, which is higher than minus 11. So we will not need a reactor. And also we will need the methanol. A question might come to mind while you are using methanol, not, of course, ethylene glycol, because it is cheapest one. I will not say cheapest. I don't like to use this item. It is more economical for re-injection and also for ice freezing, anti-freezing, and also cheaper for regeneration. Then what? As we reviewed together, we are having inlet separation, we are having methanol. After doing the injection, our curve turned to be like that. As you can notice, our operating point turned to be away. But in fact, the operating point is the same. The curve itself, which has been shifted to this right, to the left right, to the left side. Sorry for that. Our formation temperature turned to be from 18 down to minus 3 Celsius degree. Our jet skid, in fact, is formed by two heat exchangers having these specifications. Also a JT valve having this specification. Sorry, I'm going so fast because I know that you are not interested anymore from my presentation. You are hungry now. I'm also hungry. And this is our low temperature separation, which are having these skates. You know, some features from our Unison design software. It is having a quick sizing, as we see. We could figure out the size of it, the volume, the diameter, the length, and so on. And we are having also the boot and the wearing, you know, the position and the physical height. Then our curve turned to be like that. If you could notice, your operating point, in fact, got into or inside the curve itself, but this is not enough. You have to do separation. After doing the separation, you have your heaviest component, which will be separated through a low pressure separator hydrocarbon. These were the molar flow of them, and these are the compositions of them. This is your operating point, but this operating point is not for the gas. Can I ask you a question, please? This operating point is for what? Is it for the gas or for the liquid? Because I fear that you have lost your attention. I think this operating point is for the liquid itself. It is not for the gas. So it is on the left side. So after that, you will be doing a separation for it. Yes, it is inside the curve, of course. So I will do some separation after doing and inserting a low pressure separator around the rating 150 for the flange. You will have your point outside the curve. So you have in the liquid form. You can transfer it by trucks or pipeline or whatever facility is available. Then let's go back. These are your mass flow rate, and this is your composition, mainly composed. The methane and ethane, if you could notice, what is our main concern here? Our main concern is to look for, sorry, come back. Oh. He went to be hungry as well. We are reviewing together. Okay, move forward. Then you have your heart rate, and then Everyone is sleeping now, right? Okay, we moved through this, and we have our injection and dehydration.
Mohammed,
Yes.
go to the conclusion directly.
Okay, I will go. Sorry for that. But I'm just trying to make my point effective as good I can, as possible as I can. This is our operating point as we reviewed together, and this is our composition and conditions. I know it is more technical, but I wanted to make it, more beneficial for you because I know that most of you are chemical engineers. That's my point. I'm not just wasting the time,
Nobody believes that you are a mechanical engineer. We thought that you are a process engineer.
Yes, I'm having a master's degree from India for the piping engineering. This is why I'm, interested in that. These are composition. What I was going to ask you, what is your main concern here? I think we could be looking at the ethane and methane composition. As you see here in the liquid phase, you are having very low composition. That means that you are having your liquid is already separated. Then, this is your point which we were talking about, is still very close to the curve itself. So you will need to do more heating or heating the gas. It will be through heating. This heat exchanger, you will have your point in this position, which is outside the curve. But still, these conditions is not matching with the specs of the EGPC. So you will need to do out of spec. You will need to do a compressor station. After doing the compression, you have your operating point around 3.5, and then your pressure is around 73. Then the methanol regeneration, as we see, the temperature is very low and the pressure also is not matching, so we will need to increase the temperature. At the same time, you will need to cool the gas. Instead of having a cooler and a heater, we use the heat exchanger here to do both functions at the same time. This heat exchanger, then you have your composition in the aqueous state, and then you are having your sales gas with these conditions as we see: temperature, pressure, molar flow rate, and this is the operating point. You need to check for the gas composition, it's okay. 93% is methane. Finally, gas is on spec. I'm just summarizing and reviewing my presentation. We have reviewed together that the gas production is a promising industry in Egypt. And the Capital Economics has estimated we are being blessed. Our production is almost doubled. I also had an introduction on the gas processing. We have reviewed this figure together, and we have reviewed also the main components and equipment for the gas early production facility. As we see here, we have also reviewed our process, and we had our gas. I'm just trying to review with you. The conclusion: gas production is a promising industry. Gas early production facility is an effective solution for accelerating the gas production, and Petrojet, through its wide multi-capabilities, considered as a shop stop for gas early production facility. Many thanks for your attention, and these are my contacts.
شكرا جزيلا.
Thank you so much.
احنا مش عايزين زنق قوي في البروسيس كويشنز.